Okay, my name is Tanishq Saxena, and this time we will do this question. Lowest common ancestor of a binary tree. So again, it is a medium level type of question, and it has been asked in a lot of companies. So given a binary tree, find the lowest common ancestor. So if you read the definition of lowest common ancestor on Wikipedia, it is like that. See, here P and Q are given to us. We have to return the lowest common ancestor of P and Q. Okay, so what is C? First, see this example. P is 5 and Q is 1 here. Yes, so P is 5, P is this 5, and Q is this 1. So their lowest common ancestor means their lowest common parent. Yes, means when they will reach their parents, the common parent which has P in its left and Q in its right. Okay, the first parent which has P in its left and Q in its right, that is the lowest common ancestor. If I tell you in my words, so see the answer is 3 because the 3 dot right is 5 and 3 dot left is 1. Yes, and suppose now P and Q are 5 and 4. So see, our answer can include root as well, or it cannot include root as well. It depends on the P and Q. So if you see this example, P is 5 and Q is 4. So lowest common ancestor is 5 because 5 is a root as well and it is P as well. Yes. So see this example. I have this example for you. If you see this, parent of P is what? Parent of P is this 5. Yes. Let me change my color of my pen. Uh, Parent of P is 5. Yes. P parent is 5 and parent of 4 is this 2. But see, 2 dot right is Q. We have Q, but 2 dot left is not P. So we will go upwards, but we have inside this. So if you see, this 5 is the lowest common ancestor. Why? Because in its left, it has P, and in its right, it has Q, but it is root of another. It is a children of another root. Yes, it is children of this 2. Yes, this Q is a child node of 2, but it is there inside 5 of right. If you expand this root of 5 of right, see, 5 of right has 2 roots. Yes, not root, 2 leaves or 2 nodes. Yes, 2 nodes. 5 dot right 5 has 2 nodes. First is left node and second is right node. So in its right node, the root of this root 2 also has 2 nodes, and that has Q. So it means we have this Q in 5 dot right. Yes, if you check the node of 5 dot right, we have this Q. So that's how our solution, that's how we'll approach to this solution. So let's see how can we do this. I'm clearing this for see. Oh, okay, so let's suppose our P is not this. Now P is this. Okay, P is this 5 and Q is this 4. So if you see, parent of P Q is what? Parent of Q is this 2. Yes, this Q is the parent of 4. But it is again, it is in its left, it doesn't have the P. Yes, it doesn't have P. But in its right, it has Q. So it's okay. But we have Q right now. So it will go to its parent. In its parent, it will found P. Yes, see, this root is P as well, and it is a root as well. So yes, this is our answer. This and this are answer 5 and 4. So see, our answer is 5. Why? Because 5 has in its right it has Q. In its right it has Q somewhere. It doesn't mean that its next node will also it's the right node which is directly attached to this 5. Suppose this is 5 and the right node which is directly attached to 5. It doesn't mean that this will only RQ. RQ can be a root of its next node. Yes, leaf of its next node. Yes, it is possible. RQ can be a child of its next node. Yes, and RP can also be a child of its next node. So, but this is the lowest common ancestor. So let's write the solution for this. I'll write a recursive solution. Okay, so recursive solution. I'm creating a function traverse, or I'm using this old function technique. Function traverse. Yes, and it will have what? Current inside it. Yes, current inside it, and I will call this function with root. I will use a bottom up approach here. How? I will go to bottom first. I'm clearing this all this thing, and I will now I'm telling you my approach. See what I will do here. So I will go to bottom. Yes, bottom. Bottom means both left and right are null. Yes. I will go to bottom and I'll check, do I have a queue right now? If I have, I will make a marker. Okay. See, if suppose both nodes are null, this is null and this is null. So I will return 0 and this will also return 0. And this 8 is also not equal to q. So this will also return 0. This will ultimately return 0 to this. Okay. So this will also return me 0, 0 to this. And this 0 plus 0 is again 0. So means in this side we do not have. And suppose like this only. Uh, Now, this 7 dot left and right are null and null. Yes, 7 dot left and right are null. So this will return me 0 and this will also return me 0. And this 7 is also not equal to q or p. It is not equal to any of them. So it will also return me 0. But here see, 4 dot left and right are null. Yes, are null. They both will return 0 to this q. But this 4 is equals to q. So its value is 1. So if you add 0 plus 1 plus 0 plus 0 plus 1, it will return me 1. And it is returning me 0. And 2 is not equal to p or q any of them. So it is also 0. So right now 1 plus 0 plus 0. It will return me 1. So this 2 value is 1 right now. Yes, this 2 value will become 1 now. Okay, and see this 6 is also not equal to, its left and right are null only, so they will return me also 0. Just try to understand this. And this 6 is not equal to either p or q, so it will also return me 0. So this 0, but see, p is equals to this 5 is equals to p. Yes, so it will give me 1. And if I add 1 plus 1 plus 2, whenever I get my 2 anytime, first time whenever I get 2, I will update my lowest common ancestor, and that will be my lowest common. This will be my lowest common ancestor. Yes, right. Perfect solution. So I'm changing something. I will explain it to you again properly this time. So suppose my p is this, and okay. So now I will call a function with, see, whenever I call, suppose this is my traverse function. Whenever I call this with null, it will return me 0. Okay, perfect. Yes, perfect. Okay. So it will return me 0. So 7 dot left and right are null only. So it will return me 0. It will return me 0. And uh, I'm writing this. If my current is equals to p or q. I'm just writing like this. This is a pseudocode. Yes, it's not correct, but it is a pseudocode. If this happens, then I will make a count of current, which will always be 0 first time. I will increase it to 1. If this happens, I will increase current to 1. Current plus plus. Yes, I'll increase current if this thing happens. So current will become 1. Right now, current was 0, but current will become 1. So right now, see, current is 7. It is not equal to either P or Q. So current will remain 0. Yes, current will remain 0. Perfect. So, and now to its parent, I will return what? This is if block is done right now. See, to its parent, I will uh, return what? Current plus left plus right. Yes. So see, current is 0. My current is 0. Yes. This is 0. This is 0. This is 0. So 7 will have 0 inside it. Okay. This q. See, this q. Both the nodes are null. They will return me 0. They left and right are 0 0. But this q is equals to current. So current will increase. Q is equals to this 4 is equals to q. So current will increase to 1. Okay. And now my current will be 1. 1 plus 0 is what? 1. So this will return me 1. So again, this 2 is all, now this its upper function will check. See, this q, this will return me 1. So now its upper function will check, is this 2 equal to my q or p? So no, it is not equal to both of them. So it will also give me 0. And to its parent, I will return 0 plus 1 plus 0. So I will return 1 here. Now from its right, again it will check like this. This will return me 1, and 1 plus 1 is 2. This will return me 0. And if I add both of all three of them, it will return me 2. I'll update my lowest common ancestor. So that was my approach. I have explained it a lot to you. So uh, it's not that tough, but understanding this concept of making left and right and current, that is a tricky concept. Writing code is not that tough for this question. So okay, let's write it. So if my current is null, suppose at last time when I'll call it with left and right, my current will be null. then I will return 0. Perfect. Now at left, let left is equals to traverse current dot left. I don't need to worry about if left is null or not, because if left will be null, it will return me 0. Yes, perfect. So current dot right, I'll call it with current dot right next time, and I'll change this to right as well. Okay, so now we have done our task. We are calling it like this, and we need to make sure one thing. Let current, see, I was making a current variable which will be 0 for first time. Okay, and let LCA is lowest common ancestor, nothing else. So LCA is null. So for first time, see, for last, if I am at this fourth node, if I am at this 4 node, so what will happen? Suppose I am at this node, left will give me 0, right will give me 0, and current will become 1. How current will become 1? If current is equals to P, or double equal to P, or current is equals to Q, right? If it is equals to P or it is equals to Q, either of them, it is equals to either of them, then I will do what? I will do current plus plus, right? I will increase current, and then I will return, okay, return current plus left. See, left is a value right now, left is not a function, left is value at last point, RAGHT, perfect. So it will return this. So inside this, see, this left function will also calling a traverse function. That traverse function is returning current plus left plus right. So now if that happens, current plus plus. Okay, I'm doing current plus plus. Okay, and do what now? See, I'm doing current plus plus, and I'll return this. If now I have to do one more thing. If at any time, if at any time uh, our left plus right plus current is equals to 2, suppose at any time, and my LC is not valid for first time, my LC will not be valid. Yes, LC is not valid, not or, and my LC is not valid. I will do what? I will increase my not increase, LCA is equals to current node. Yes, LCA will be equal to current node. So right, our code is correct right now, and yes, this should be the code. And let me return LCA to see. I'm doing this to see is my code correct or not. So okay, current is 0, current has already been declared. So okay, I need to do it count. I'm doing it count. Yes, not current. So control C. If count plus plus, and count here as well, count, and LCA is equals to current only. Yes, so right now I'm doing it right, and this also to count. Yes, so now see, is there any other error we are doing? Traverse here. Okay, see, this is running perfectly, and it will be accepted, I know that. See, if I run it, this will be submitted. And so, okay, I didn't submit it, I just run it. So now I'm submitting it, and it's pending loading, and it should be submitted. Okay, so see, our code is accepted, and it is accepted in 15.7 milliseconds. So its complexity is what? Let's analyze its complexity first. So its complexity is we are doing traversal for first time only, and recursion O of n. Yes, O of n, basic, very easy. So O of n, yes, perfect. So its complexity, that's a very easy code for this. And yes, this was a medium level question, because see, the medium thing is here, that only left, right, and count, making your left, right, and count. Otherwise, this question, writing code for this question is not that tough. So thank you so much. That was my solution for this question.